In the past, we've seen simultaneous equations, so that's like two equations and two unknowns that we've seen. If you thought that was fun, we're going to do three equations with three unknowns in this video. So you can do this on your calculator, absolutely. If you open up your calculator and go down to equation mode here, simultaneous, three unknowns. And then in here, we need to put all the coefficients. So 1, 3, and 1. 1x, 3y, 1z equals 12. And then follow along. Minus 1, 2, 3, 11. 2, 7, minus 1, 21. And then hit F1 to solve it. And we should get 1, 3, 2. So that is the answer that I'm expecting to get. X is 1, Y is 3, Z is 2. But you do need to know how to do this by hand. Exam questions quite commonly will swap out one of these for like a letter or something, and then you just can't do that in your calculator anymore. So we do need to know this process. We're going to use something called row operations, and you need to start by writing it in an augmented matrix. That augmented matrix is actually pretty much what we just put in the calculator, with a big line down the middle. So it's the coefficients of x, y, and z, like that. So it comes from your x bits, y bits, and z bits, and then the constants there. That's where those bits come from. And then you just close off the matrix there. Now, our goal is going to be to do this augmented matrix until we get to something that looks like this. It should have zeros down the bottom left corner in a little triangle, and then whatever you want in the other spots there, and whatever you end up having in for the constants. And we're allowed to do certain row operations. So the row operations we can add rows. We can multiply a row by a constant. So you can't multiply two rows together. You can multiply a row by a constant number. And we can swap rows. That last one is not super common. We don't see swapping rows a lot. But if we already had zeros here somewhere, like if that number was already a 0, I would swap this row down to the bottom or something so that, well, probably I'd swap it into the middle spot so that the 0 would be there. But we're not going to be swapping any rows yet. Okay, with row ups, you can do two at the same time. So quite commonly, these two will come as a pair, doing them together. So how can we get this 0 here? I need to use my row operations to do it. The easiest way is to add the first two rows together. So the first row, you basically never touch the first row unless you like swapping it. But the second row will become a new row made up of row 2 plus row 1. So row 2 plus row 1, I'm going to get minus 1 plus 1 gives me 0 there. Okay. Then I'm going to get 2 plus 3 should give me 5. I'm going to get 1 plus 3 should give me 4. And then I'm going to get 12 plus 11 should give me 23. Cool. So we got a 0 where we want it. We'll put a little tick there. We're on track. Now, the next row is a little bit more tricky. We can't just add the rows together. We would get 3 in the bottom left corner if we add the rows together. We can't just take them because we'd get 1. What I need to do is I need to send row 3 to become row 3, take 2 lots of row 1. So I get 2, take 2. I get 0, cool. I get 7, take 2 lots of 3. So 7 take 6 is 1. I get minus 1, take 2. And I get 21, take 2 lots of 12. So 21 take 24 is minus 3. Now, these operations may look very familiar. They're actually just the operations for simultaneous equations when you do elimination. Elimination, we add two equations together is basically what we're doing. And this operation here was a combination of those two row operations at the same time. So we took row 1 and we times it by minus 2, and then we added it to row 3. So we did those two row ups, it's just they were combined. Okay, next, well, we've got 2 of the zeros that we wanted. We just need that last one. If you try to do row 3 with row 1 again, it just never ever works out. you've got to combine row 3 and row 2 now. So that's how this works. So row 1 and row 2 will stay the same. Row 3 can go to 5 lots of row 3, take row 2. So, in fact, I'm even going to do that the other way around. It's going to go to row 2, take 5 lots of row 3, just because that'll give me a few less negative numbers. So, let's think about this. So, for this spot here, I've got row 2's value, so 0, take 5 lots of 0. So I've got 0 there. This was where I was hoping to get 0. So I'm going to have 5, take 5 lots of 1. Hey, I got 0. Cool. Excellent. In this bit here, I've got 4, take 5 lots of minus 3. And you can see why I've swapped the order now, because that gives me big positives. That gives me 19. And then let's go in here. I've got 23, take 5 lots of 3. So that's going to become 23 plus 15. So that's going to give me 38 there. Okay. If I had done the original row up that I wanted, if I'd done 5 row 3, take row 2, these would have just been minuses there. That's all that would have happened. Okay, so now that we've done that, we can read off the solution to our equations, because we got zeros in all 3 of the spots where we wanted zeros, which is good. Okay, bottom equation is 19z is 38. So we can just solve this like a normal equation. Z is 38 over 19, which is 2. So that's already matching that. We're very happy about this. Then we sort of work our way back up. So that was from the third equation. From the second equation, or second row, we can read this row back off as 5y plus 4z is 23. So that's 5y plus 4 lots of 2 is 23, because z was 2. So 5y has got to be 15. So y is 3, which is what we wanted, so that's good news. And then from equation 1, you've got x plus 3y plus z is 12. So that was reading off the top row. And we can just plug in the numbers that we want. So y was 3, z was 2. So x plus 11 is 12. So x is 1. So our solution is 1 for x, 3 for y, 2 for z, which is exactly what our calculator said the answer would be. Now, the question is, how do we interpret this geometrically? When we had a 2x2 system, it was 2 lines that were intersecting. Now, based on a couple of videos back, these are all equations of planes. So let's have a look. All right, so I put the 3 plane equations into GeoGebra. You can see that they're sort of doing this, and they do all meet at a point. So that point is the point we just found, 1, 3, 2. And you can see that that point A is where all 3 planes are meeting together with each other. It's the only spot where all 3 planes meet. Now, as I'm sure you might be able to imagine, it's not always a point. Planes can do all sorts of funky things. In fact, there are like 8 of these possibilities. We happen to have number 6 there, but we can work through that. So planes meet in a point. Let's do this one. So you absolutely can solve it in your calculator, but we're going to do row operations, so we're in good practice at that. Quite often I'll just be asking you to solve these by hand. Okay, so we got to get zeros in like a triangle in the bottom left. Conveniently, we can actually just do that same first step we did before, row 2 plus row 1. So that becomes 0, 5, 4, 3. Then we got to go row 3 goes to row 3, take 2 lots of row 1. So if we do that, you're actually going to get 0, 0, 0, 15 take 2 is 13. Okay, so that's concerning. That sometimes happens, and that's fine. Basically, that bottom equation there, we could read it off as 0x plus 0y plus 0z equals 13. So 0 equals 13, and we broke maths. All right, whenever you break maths, it means that you've made an assumption somewhere earlier which was wrong. The assumption that we've made was that these did intersect. If you try and make them intersect, you get 0 equals 13, which is silly. So therefore, no common intersection point. Now, you have to think about what this looks like. You can tell whether two planes are parallel to each other if their normals are multiples of each other. So let's look at the normals of each of these planes. So that's going to be 1, 3, 1. The second normal is -1, 2, 3. And the third normal is 2, 6, 2. Now, the bottom one is double of the top one. So therefore, plane 1 is parallel to plane 3. So probably what this situation looks like is you've got, here is plane 1. Now, there's two things that can happen. You could have plane 1 being there and plane 3 sitting right on top. This is if the whole equations are multiples. So that would be the case if you just doubled the top equation to get the bottom. So that number would be 2 if that was the case. That number is not 2, it's 15. So this is not in this question. So that is not what's happening here. What's happening here is that plane 1 is parallel to plane 3. And then we probably got plane 2 just sort of like sweeping in. Well, that's a terrible plane picture. But plane 2 is sort of like sweeping in something like that. So there's no point where all three of these planes meet because plane 1 and plane 3 never meet each other. And if we draw a picture of all three of these planes, you can see that sort of happening. Like there's two planes that are parallel, and then the third one's cutting through both. There are no point where all three of them meet. All right, so no common intersection point as plane 1 is parallel to plane 3. So that's how you interpret that. We can also look at what happens when you put this into the calculator as well. So we said there were no intersection points, and if you hit solve, it just says no solution on the calculator. Okay, we'll look at this other thing that can happen. So this will chuck into an augmented matrix. 1, 1, 2, 4, 1, 2, minus 1, 1, 2, 2, 4, 8. You might already notice that the bottom equation is 2 times the top equation. And in this one, it almost was, apart from that very last bit, wasn't. However, now in this one, the entire equation is 2 times the top equation. So we'll see what happens there. Okay, so that's 1, 1, 2, and 4. Row 2 can just go to row 2, take row 1. So that becomes 0, 1, minus 3, and minus 3. And then if we try and do this row operation here, row 3 should go to row 3, take 2 lots of row 1. That gives us 0, 0, 0, and 0. So basically, in this one that we had up here, the bottom of the augmented matrix looked like 0, 0, something that wasn't 0, and then doesn't really matter what that last thing is. That was the 1 solution. In this one here, the augmented matrix looked like this. So it looked like 0, 0, 0 on the bottom, and then something that was not 0 there. So that was the no solutions version. Here, the bottom row looks like 0, 0, 0, 0. Now what it means here is that we have infinitely many solutions. Okay, so we'll see what happens. You basically need to throw out the bottom equation, and you say from the second equation, y take 3z is minus 3. Now, we need to say let z equal t, and t can be any real number. So this second equation becomes y take 3t equals to minus 3. And so y is going to be minus 3 plus 3t. Now looking at equation 1, it's x plus y plus 2z equals 4. And we can plug in what each of those things are. So y was minus 3 plus 3t. And that's two lots of, so z was t, and that equals 4. And then we can just deal with this. So x take 3 plus 3t plus 2t equals 4. And so x is, so we're going to bring the 3 over here. Or we might do it in 2 steps. Take 3 plus 5t equals 4. So x is 7 take 5t when you rearrange that. So we sort of got this situation. You've got x is 7 take 5t. Y is minus 3 plus 3t. And z is t. And that is the equation of a line. So all 3 planes meet in a line. So it's probably going to look something like this. So there's your line that the planes are meeting on. You might have another plane through it like that. And then you might have like a third plane through it, which I'm going to be really bad at drawing. Basically like that. So yeah, all 3 planes will meet in a line there. Alright, so you'd say something like this is your interpretation. And the bottom, all 3 planes meet in this line, and then give the equation of the line. If we look at it on GeoGebra, basically you can see 2 of our planes actually overlap each other. So I think it's 1 and 3, which are both the same plane. So it's a little bit different to the picture I drew, but they do still meet in a line. And we can actually put the equation of this line in as an equation on GeoGebra too. 7 take 5t minus 3 plus 3t. And t. And if I sort of graph that line, you can see that it is where the planes all go through. Just like that. Wonderful stuff. All right, the other thing you can do is just check on your calculator. So if you put all that into equation mode, so that was just, equation simultaneous 3 by 3, enter all the coefficients from there, you should get this as your solution. Now your calculator uses z instead of t, but it's the same sort of thing we just worked out there. And we've seen, 3 of the 8 things that can happen here, but pretty much always it's either meeting in a point, meeting in a line like number 7, not meeting at all like number 4 or number 3 or number 8. And then I guess the only other thing that can happen would be that all 3 planes are all on top of each other, so then they meet in an entire plane. So yeah, there's lots of different things that can happen, but it's usually a point, a line, a whole plane where they're meeting or not meeting at all.